All right, let's get straight into it. Today, we're going to break down a classic GCSE maths question all about box plots. We'll be digging into question 11 from a higher tier paper and using the official mark scheme to figure out exactly how to lock in every single one of those valuable marks. So here's our game plan. We'll kick things off with the exam question itself, then we'll decode the data they give us. After that, we'll get into drawing the box plot, and then we'll absolutely nail the statistical comparison part. We'll even have a quick look at an alternative version of the question before we wrap everything up with some key takeaways for you. Let's dive in. Okay, first things first. Let's look at the challenge exactly as you'd see it on exam day. And here it is, question 11. We're told that Mina has been recording car speeds on a Friday and has put the data into this table. Part A, for a cool 2 marks, asks us to draw a box plot. Then Part B, worth 3 marks, asks us to compare Friday's data with some data from Sunday. Now, before we can even think about drawing anything, we've got to make sure we have all our information lined up. A quick glance at that table shows we're actually missing a couple of key values. So our first job is to work those out. Right. To draw any box plot, you always need 5 key pieces of info: the lowest value, the lower quartile, the median, the upper quartile, and the greatest value. The table gives us some of this, but you'll notice we don't have the upper quartile or the greatest value. So let's go find them. First up on our treasure hunt is the upper quartile, or UQ for short. We can figure this out pretty easily by adding the interquartile range to the lower quartile. And hey, the table gives us both of those. So let's do the math. We take the lower quartile, which is 35, and we add the interquartile range, which is 12. And that gives us a nice, clean upper quartile of 47. And believe it or not, just by doing that simple sum, you've already started earning method marks. Next, we need the greatest value. This one is just as straightforward. It's simply the lowest speed plus the range of the data. And again, both of those values are sitting right there for us in the table. So we grab the lowest speed, 25, add the range, which is 37, and that gives us a greatest value of 62. And just like that, we have all the puzzle pieces we need. So here it is, our complete set of numbers. We've got our 5 champions ready to go. Lowest speed is 25, lower quartile is 35, median is 40, our freshly calculated upper quartile is 47, and our greatest value is 62. Perfect! Now that we've done all the prep work, let's build the answer for Part A and see exactly how those marks are handed out. Okay, this is brilliant. This is taken word for word from the official mark scheme. It says you get the first method mark, an M1, just for correctly finding either the upper quartile as 47 or the greatest value as 62. So all that work we just did has already put us on the scoreboard. And the second mark? Well, that's an accuracy mark, an A1. This is for a fully correct box plot. All that means is, did you take your 5 values and draw the box and the whiskers in exactly the right places? If you did, that mark is yours. So to bag that A1 mark, you'd plot these 5 points on the grid provided. You'd draw a little line for the lowest value at 25, then you'd start the box at the lower quartile of 35, draw a line inside the box for the median at 40, and the box at the upper quartile of 47, and finally, draw the last whisker out to the greatest value of 62. Done. All right, Part A is in the bag. Now for Part B, which is all about the art of statistical comparison. This is where you need to interpret what the numbers are really telling us when we compare Friday speeds to Sunday speeds. Now listen up, because this is absolutely crucial for getting full marks on these comparison questions. You almost always have to make 2 points. First, you compare a measure of location. That's just a fancy way of saying an average, like the median. Second, you compare a measure of spread. This tells us how consistent or spread out the data is. Think of it this way. The average tells you which day was faster overall, while the spread tells you which day had more predictable speeds. You need both for the full picture. So let's see what the mark scheme accepts. For your first point, you get a communication mark, a C1, for comparing the medians. You could say something just like this. On average, speeds are slower on Sunday as the median is lower. It's perfect because it links the statistic, the median, to a real-world meaning, slower speeds. And for your second point, you'll get another C1 mark by comparing the spread. A top-tier answer would be something like, the speeds are more consistent on Sunday as the interquartile range is smaller. A smaller range means the data is less spread out, so it's more consistent. Simple as that. Okay, here's a neat little tidbit.
Exam boards sometimes use slightly modified papers, so what happens if the numbers in the question are a little bit different? Let's see if our method holds up.
In one version of this paper, the IQR was 10 instead of 12, and the range was 35 instead of 37. The other starting numbers were the same. So, how does this change our attack plan? Well, here's the big reveal. Of course, the numbers change, right? Our UQ and greatest value are now different. But does the method change? Not one bit. You still add the IQ to the lower quartile, you still add the range to the lowest value. The process, the thinking behind it, is 100% identical, and that's the real key. So we have totally taken this question apart. We've done the calculations, drawn the plot, and made the comparisons. Let's wrap this all up into a clear, simple strategy you can use in any exam. Here it is, your go-to strategy for box plots. First, always make sure you have your 5 key values. If any are missing, calculate them first. When asked to compare, remember the magic number 2. Make 1 point about the average, that's your median, and 1 point about the spread, that's your range or IQR. And please, please remember, trust the method. The numbers might change, but the process is your best friend. I'll leave you with a final thought to chew on. We know exactly how to calculate the upper quartile. So what's a really common but simple mistake a student could make that would cause them to plot it in the wrong place? Thinking about the potential pitfalls is one of the best ways to make sure you don't fall into them.